Bente, we don't hear you.
Thank you. Welcome also with sound now. My name is Bente Lilja. I'm going to be the host of this final workshop of the EO4Agri Horizon 2020 project. We have a panel of speakers with us today, and we will introduce you to the program shortly, but first you will meet our speakers. Can I get all my speakers on the camera, please? Hello, everybody. We are going to be live on this workshop for about 1.5 hours, so you can plan your time. We have a chat where you can ask questions and comment, and we will also share some information in that chat, so be following that. Let us know where you come from. That would be great for us to know. Before we start on the program, before I introduce you to the concept of this 1.5 hours, or actually for two days, we will introduce ourselves. And I give the floor to each of the speakers. Let us start with you, Gerhard.
Good afternoon. All right. Yes, my name is Gerhard Triebnig. I'm happy to be here. I'm based in Austria with my company EOX IT Services GmbH. We are involved in Copernicus information infrastructure work, mainly for the European Space Agency, and we have been happy to also contribute our technology expertise to the EO4Agri project in this field. Thank you.
Lovely to have you here. And then Karel.
Hello, my name is Karel Charvat. I'm from Czech Republic, but I'm also working for Club of Austriach in Austria. I am working all my life about remote sensing. I started already in '83, and now I am active also in a number of international organizations like Open Geospatial Consortium, International Society for Precision Agriculture, Research Data Alliance, and other.
Very active indeed. And David, you're muted too. David, you are muted. Okay. So there's something with his sound, so maybe David, you can go in and out again, and we will learn more about you later. Meanwhile, we can learn about Laurent. Remember to unmute yourself.
I was unmuted.
Oh, sorry.
Yeah.
The same problem. Sorry. Good afternoon, everybody. I'm Laurent Clergue. I'm work for Atos France. I'm based in the south of France, and I'm responsible for Atos of products based on space imagery. And I'm responsible for this project EO4Agri of the catalogue of services.
We are looking forward to see more of that towards the end of this webinar. And David, I think I heard you.
Let's give it a try again. Okay, I was unmuted, but technical problems always occur. Back to me. My name is David Kolitzus. I work at GeoWill. It's a company based in Innsbruck, Austria as well. And we are mainly focusing on land monitoring services and solutions, and are a service provider to different customers. And also this in the EO4Agri project, we focus on solutions for land monitoring purposes, which you will hear more about later. Thank you.
Excellent. Yes, and the person who is coordinating us all, last but not least, Miguel.
Thank you, Bente. So my name is Miguel Esbri. I work for Atos Spain, and more specifically in the Research and Innovation Department. I am involved mainly in European projects related to Earth observation and geospatial data management. And as Bente mentioned, I am the project coordinator.
Yes, indeed. Well, I forgot to tell a little bit about myself, actually. So I'm representing Plan for All in the EO4Agri Consortium. I'm a member of the steering committee of Plan for All, but I'm also representing Norway in GEO, the Group on Earth Observation, in the program board of that organization. So generally speaking, I know a lot about Earth observations, data sharing, interoperability, and also how it can be applied. So that, with that, having that introduction done, yes, I think I will introduce you to the concept of this final workshop. I see that somebody has raised their hand, and that's absolutely an option. If you want to speak in this room, you can raise your hand. But right now we are fully booked. There are room for 6 people here. So, but after 3 o'clock, Miguel will have to leave. So after 3 o'clock, we will actually be able to invite those of you who are interested and have a certain user requirements are necessary. You have to have a very fast or stable internet connection. You need to have a Chrome browser, a webcam, and a headset. If you have that, we will be able to invite you in, and all you need to do is to raise your hand, and then you can comment and ask questions inside the room with us. Otherwise, we do encourage you to write questions and comment in the chat, and we will answer them the best we can. And you will learn that there will be another way of engaging with us. So I will explain that now. So with that, I will share my screen, and you will be able to see the concept of this workshop. So we have 2 sessions, and today we are going to focus on technical insights on the use of Earth observations for agricultural applications. Tomorrow, we will look more on the policy perspectives in the workshop we call EO4Agri Strategic Research Agenda and Roadmap. But these are, of course, highly linked. And so first, we will go through the different technical perspectives on Earth observation and agriculture. And then you will see that this is the basis for what we are going to talk about tomorrow. You will see this again, but today we will focus on the technical aspects. And more specifically, what we are doing now is the overall concept of this event. Then Miguel will introduce you in more detail to what the EO4Agri project is all about. Then we will dive into user requirements and gap analysis for the use of Earth observation data in agriculture, and Karel will give that report for us. Then we will look at methods for agricultural application, and David will do that for us, and Gerhard will introduce infrastructure and software for these areas. And finally, we will also get a demonstration of the EO4Agri catalogue by Laurent. And in the end, we will have a Q&A sessions inside this room. And after we end, we plan to end at 3:30. So we will have 1.5 hour workshop in this room. Then afterwards, we are offering an opportunity for you to engage more directly with the speakers. So we have set up so-called coffee tables, so virtual coffee tables where you can just join informally at a table where you see that an interesting topic is being discussed. And Karel and David and Gerhard, they will be in this coffee table room, ready to discuss and deepen a little bit more about what they are going to present, because they are only going to have about 10 minutes presentation, so they cannot cover absolutely everything. However, you will be able to discuss with them in around the coffee table, a virtual coffee table, And you can, if you're not already registered or have an account on AirMeet, I recommend that you go there and do that now, so that you are ready to just click on a link that we will share with you in the chat. So we will share a link to the meeting room where we have coffee tables during the workshop today. So this is the program that we have for today, and you also see how this is linked for tomorrow. We will also provide you, if you haven't already registered for the event tomorrow, we will provide a link so that you can secure your seat there as well. So this is the concept of the final workshop for EO4Agri. We are very excited to share the results with you. We have engaged with so many of you, as you will learn during these 2 days. And I think we are ready to give the floor to you, Miguel, so that we are all reminded about the entire EO4Agri project.
Okay, thank you, Bente. I will share my screen.
Yes. And we will turn off our cameras and mute ourselves while you are giving your presentation, Miguel.
Okay, thank you. Okay, so this will be a very high-level introduction to the project, because my colleagues will afterwards present in more detail the different aspects of the project. So the project is called EO4Agri, which stands for Bringing Together the Knowledge for a Better Agriculture Monitoring. The main objective of the project is it's a coordination and support action, so it's not really implementing any technical component or software, but it's more on collecting requirements from different stakeholders and existing and past projects, and try to find gaps and things that could be improved in the Copernicus program in order to improve the European capacity for the agriculture monitoring. It's a project that was funded under the SPACE program. In fact, here there were 2 more projects funded that were related to forestry and the Antarctic monitoring. The project started in November 2018, and in fact we are finishing the project in October in this year. The coordinator is Atos Spain, as I mentioned before, and the consortium is composed of 11 partners that comprehends research and academic institutions, Earth observation data providers, industry like Atos, also which is linked to the DIAS, one of the DIAS providers. Also SMEs, which are related to the Earth observation, processing and management, and the public administration, in this case, our Lithuanian partner related to the National Patent Agency of Lithuania. Okay, we have 7 high-level objectives. The first one is to develop the community building concept, which allows us to analyze the community needs and find a common ground for cooperation with them. In relation with this, the second objective of the project is to identify a set of sectors that are using Earth observation for agriculture, and more specifically, subsectors within this agriculture domain. So the project is focused on the agri-food sector, the public sector, and more specifically the CAP management, the financial sector, including the bank and insurance companies, and the food security. With the requirements collected from those stakeholders, the idea was to develop a set of scientific and technical guidelines, which would allow us to identify the existing gaps. And the idea was also to focus in this aspect in 3 different areas within agriculture, which are the precision farming, yield forecasting, improvement of the future emissions support for thematic applications, and the Earth observation ICT support improvement. All these aspects will be later on covered in this session. Also, an important aspect of the project was to analyze the existing infrastructure also with looking forward in the future on how this could be improved in relation to Copernicus. So the project did a complete assessment of the whole value chain of the Copernicus system of systems, going from the Copernicus upstream to the Agri apps that are currently existing in the market. And all this information was consolidated in the catalog that afterwards will be presented by Laurent. Also, important part of this project was to, with all the insights gathered from the other objectives, was to develop two main deliverables, which are the policy review, which is a set of recommendations based on the gaps and improvements identified in the other activities that would allow to strengthening the impact of the Copernicus program and to further develop the CAP policy at national and regional level by the different policymakers. Together with this, the project is also providing a strategic research agenda on Earth observation for agriculture, and the idea was to identify major challenges related to the identification and utilization of Earth observation information together with the standards and how this could be improved and used and promoted in the different research areas that the European Commission is funding. And last but not least, of course, one of the main objectives of the project is also to disseminate all this information to different initiatives and stakeholder groups. As I mentioned before, we are focusing in four main stakeholder groups, which are the food security, the public sector, the agri-food sector, together with farmers and suppliers, plus the financial sector, and which includes the insurance and banking companies. So we expect that the main impact areas of the project, we are at least hope to have achieved that, is that with the insights that we are providing, this will allow to go for a data-driven farming experience where applications and existing tools and services can be improved and used by fueling them with Copernicus data. Also that, for instance, the financial investors and banking can incorporate this data into their own internal processes. So when they are evaluating risks in order to provide funds for the stakeholders. Also that the global food security initiatives can benefit from using this Copernicus data, as it is a massive data source which has a large cadence of periodic information, and is also open, so this could be used for them to assess the food security. Also for the public sector, as I mentioned, to use our findings in order to guide the different research agendas that are, for instance, in the Life Plus program or the Horizon Europe program that will start next year. So with the gap that we have identified, we hope that this could be used by the European Commission in order to promote the different topics that they will be funding this research. Also, in relation to the public sector, the idea from going, and more specifically from the CAP part, from moving to the on-the-spot checks to the monitoring, checks by the monitoring, by using the continuous stream of satellite data provided by Copernicus. And of course, and this is very linked with the European Commission, promoting the further use of DIASys as Copernicus data provider and be able to develop and deploy on top of them other new services that are using Copernicus data together with new algorithms, machine learning, and data queues, and so on. So the project is comprehends 6 different work packages. Work package 2 is focused on the user requirements definition and collection methodology. Together with work package 5, it defined the community building concepts and the different approaches to targeting the stakeholders in the 4 sectors I mentioned before. All this input is then used by Web Package 3 and Web Package 4, which are the more technical, to say so, web packages that are analyzing these requirements and providing feedback to those other 2 web packages which are more close to the stakeholders. And this, of course, is in a more horizontal manner addressed also by Web Package 6, which is also disseminating the results of the project and also defining the policies I mentioned before. Okay, so as I mentioned, we have these 4 stakeholders groups. For each of them, since the domain is too wide, we defined a set of specific mandates for each of them. So the project focused specifically on specificities of those sectors. So what we did is to develop a foresight methodology in order to be able to, based on those mandates, collect the requirements from those stakeholders groups and perform the gap analysis I also mentioned before. The main outputs of all this process, you will see it also specifically tomorrow, are 4 main deliverables, which are the white paper on the use of Earth observation and more specifically Copernicus data, the strategic research agenda, the collaboration framework, not only from EO4Agri project to other projects, but also other national and international initiatives like the World Bank, the European Commission, different DGs, and so on. And finally, also the policy roadmap, which will provide insights to policymakers on specifically CAP, but also other areas on how they could take advantage of the use of Copernicus data. So the requirements gathering consisted of different aspects. So first, what we did is to make a assessment of the existing requirements collected already by other projects, ongoing and past ones. So this was very helpful for us, also because we, as partners, were also involved in some of them. So this provided us with insights on what's the current status of using Copernicus data in the different European projects. This was complemented together with the 3 workshops that we organized in the project. In fact, this is the 3rd and last one, as Bente mentioned. And this was also complemented with the co-organization of training activities and Inspire hackathons, which allowed us to collect also requirements from the point of view of those who are, in fact, integrating and using the data in their own applications. Apart from this, we also carried out some other activities related to interacting with other users and organizations, like we attended to specific stakeholders events like the EU Directors Paying Agencies conferences, or the PANFARRAY conference, where the managing directors are also involved. Also together with meetings with other projects, as I mentioned, and also disseminating the results and collecting feedback from other international organizations like OGC, FAO, GOLAN, and RDA. Also, to go very quickly, you will see this also later. For each of those sectors, we organize the requirements or prioritize into top 10 requirements from each of the sectors. In this case, I'm showing here the ones for the financial sector. So we identified for each of the areas in that stakeholders group and the different features of functionalities that they will need to address, together with the specificities of Copernicus data or Copernicus derived data that they need for their internal processes. As I mentioned, we did it for each of the for stakeholder groups, we came to a very large set of requirements. Of course, this was not possible to cover in the project duration, so we just decided to prioritize them and focus in the ones that you see here. I will not go in detail on them. Also to mention that all this is reported in different deliverables that you can find in the web portal. Also, an important aspect that was covered is from the ICT point of view. So it was performed a detailed elaboration of the ICT technologies that are currently used to exploit Copernicus data. This allowed us to have a deep understanding, make a comparison of the different DIAS offerings that are currently available and the state of the art of the implementation on each of them. We also carried out several interviews with different startups, initiatives in the agriculture sector, also to understand their business and the market potential for them. And we also carried out a study and assessment of the different service technologies that are offered by the different DIASes in terms of how to access the data, the different APIs they provide, the dashboards, and so on. Also, and this will be slightly explained today, we carried out a whole analysis of the full Copernicus value chain, going from the, as I mentioned at the beginning of the presentation, from the upstream part of the Copernicus chain to the agri apps that are developed. And in the middle, of course, we have the different cloud, DIAS, and other infrastructure that is supporting the access and processing of all this data. The methodology that we used is based on the RMODP, which is used by the GIGAS project, and we adapted to this project. So we are analyzing this full chain from 5 different aspects: from the enterprise viewpoint, which is related to the different needs and requirements from the stakeholders that we have in the project; the information viewpoint, which is covering the different data flows data that is used by the different part of the value chain; the service viewpoint, which comprehends the different components that make part of that chain, together with the engineering viewpoint, with its focus on the underlying infrastructure that is supporting all those components that are deployed in the chain; and the technology viewpoint, which is more referring to the specific technologies that are used in each case in order to implement or that have been used to implement those components. Just a very quick summary of what I mentioned during my presentation. So today we will be focusing on the higher part of this diagram. So we will be explaining the different requirements that we have collected together with the gap analysis that we performed. And as part of Work Package 3 and Work Package 4, we will be explaining the different ICT technologies and assessment of the agri apps. Tomorrow, the presentation will be more focused on the different policy reports that we are currently finishing in the project. So that will be the policy roadmap and the strategic research agenda, together with the white paper, which is a consolidation of all the results of the project. Just to very quickly go before I finish, this is the web page of the project. I would, if you would like to visit it, in case you don't know it, you will find here all the information we will be presenting today, together with the catalog and the agri apps that have been assessed during the project, together with all the deliverables and reports that we have produced in the project. Not all of them are already online because we are having the final review of the project at the end of next month. So once they are approved, we will be uploading the final version of the existing deliverables. And that will be all from my side.
Thank you very much, Miguel. And you can unshare your screen, and we can come back to the mosaic. So as you saw, there's a lot of material for you to benefit from. Miguel will unfortunately not be with us longer than until 3 o'clock today, but tomorrow, Miguel, you will be able to engage in also in discussions in the informal meetings after the workshop itself, right?
Yes, exactly.
Yeah, so you can ask Miguel questions today in the chat, and we will see if we can answer those questions after Karel, or at least before 3 o'clock. So don't be shy, ask questions to Miguel. And you have also the links to the website is also as a sticky message here, and you also will get more information. But by all means, ask questions to Miguel. We will answer them in before 3 o'clock today. Otherwise, you will be able to talk to Miguel tomorrow afternoon. Karel, I think we are a little bit behind the schedule here. Can you quickly introduce us to the user requirements and some gap analysis that you did?
Okay. Oh, sorry. Do you see my screen?
Yeah, but it's not in the presentation mode.
Yeah, sorry, I need to start again probably.
Maybe choose another. Yep.
Yeah, probably I choose another window. Yeah. I think that now.
Yes.
Okay, I will switch off my camera. Hello, hello everybody. I will try fast to explain you our work on the collection of the user requirements, and also to put some effort to explain some main achievements or some very important topics which we recognize. These two reports are already available on our portal, so you can go to the detail. But I think that on the beginning I have to say that our work was strongly influenced by two things. As one thing is that during our project was announced by European Green Deal and Destination Earth initiatives, and these both are very closely related with EO4Agri, and of course with COVID-19 pandemic we had to change the style of our work. Probably you all heard about Green Deal. We have here farm to fork towards a green cap, but also biodiversity and other things are very close to agriculture. And generally we see Green Deal as the big opportunity for Earth observation in agriculture, and on other side we see Earth observation as one from important tool to be possible to realize the goals of Green Deal, because we will need to improve knowledge management to be possible to reach all this goal. And there is other very challenging initiative. It is the Destination Earth, and related with digital twins. And of course, although this will be from big part based on Earth observation, not only, of course, satellite Earth observation, but also in situ and other topics. Before COVID-19 came, we succeed with some meetings. I will shortly mention last two meetings which we succeed, and it was our participation on the Geo Week in Canberra, where together with other organization, GeoGlam and other, we organize the meeting Knowledge Management for Agriculture, which help us also to make the good link with other organization. And the last things was Prague Week of Big and Open Data and Innovation Hub, where we met with different group of people. We organized also special dedicated workshop for EO4Agri, and there were also hackathon. Miguel already mentioned that hackathon we use as some tool for collecting of information. But after Prague, shortly we had to move to online, and the rest was organized online. And I will only fastly go through some things. One was the hackathon in which initially had to be finalized in Kampala. It was only virtual. You can see that during this we cooperate with number of important initiatives, but also with a huge number of the projects which help us to collect information. We cooperate with GNSS agency, and we organize also event together. And as also Miguel mentioned, important part of our exchange of information was the technical committee meeting in OGC, where we organized at the beginning in situ and last two virtually meetings related to agriculture and Earth observation, and try to collect also different inputs for our study. It was also mentioned that we work in 4 directions: farm, financial, common agriculture policy, and global food security. I will now go to the beginning fastly to the farming sector or private sector, because we had there 2 groups, and one was mainly focused on precision agriculture and farming. You will have also some possibility to learn more in technical presentation. But what I see as important, and what is very often mistake of the people who are defining or designing some solution, is that the solution as usually designed as end solution for farmers. But in reality, there is big added value chain, and not all information is possible to go directly with the farmers, because they have no skill, and you need to put together a number of people, and this also will build some requirements for the future. We collect through the questionnaire some information about farming sector, and there are something what I put as very important. Yes, many farms are small in Europe, and if we will go outside of Europe, usually much smaller, mainly in Africa, where we done a lot of activities. And one from the important message is that something like 70% of sector required information, which are more precise, that for example is now able to offer Sentinel-2. So we have to thinking about this. And on other side, unfortunately, if we are looking on the ability or willingness of the farmers to pay, as 2/3 of answer are that they are able to pay less than €5. So there is on one side requirements for more and much better information, but on other side some market potential is limited by this fact, because it depends what will be return of investment of the farmers, and from this you can receive such sums. It is not only our investigation, it was done also by Copernicus market analysis. They came to similar things. Other thing, and this could help us a little solve this problem, is the question of food sector, because food sector is also important, and very often mainly food sector which is producing niche product are ready to finance some or part of activity for farmers to be possible increase the quality. There are such issue like Barilla or Nestle, they are already running services for farmer to have better primary production for their products. So very shortly again about this primary sector, it's required better resolution, higher frequency of the data. It is important to integrate with farmer data and other data, and of course the part of the data are only offered by commercial providers, so it is necessary to thinking how in the future we can combine the data from open data like is Copernicus on Landsat with commercial producer. What is also important that we need to look on the precision farming in some broader way, and now most of things is focused on where we will do some operation, but the timing is more and more important, and also for later selection of crops or selection of chemicals will be important. And in all cases we receive as one from the most important topic climatic data. And I think that this is also very similar in financial sector, that climatic data in the combination with classical Earth observation data are something what is very important, and there is possible to divide this into 4 parts. Already Miguel mentioned this, and it is insurance acceptance, risk prevention, damage assessment, and fraud detection. So if you will look detailedly on this, what is required by financial sector is in some way overlapping with the needs of farmers, and there is a chance if we will combine in processing in a good way that we can combine the requirements from more sites, and we can go with the cheaper price. As here is top 10 requirements for insurance and soil moisture parcel, vegetation growth monitoring. These are exactly the things which are required by farmers. Public sector, it is related with paying agency, or till now it was mainly related with paying agencies, yes, and there are again priorities coming from paying agencies, but now if we are looking on Green Deal, there will be necessary to include it into this topic also other part, Ministry of the Environment, regional government and other, because a lot of things will be not directly related only with the subsidy system, but also with increasing biodiversity, with water management and others. So in the future we have included also other part of government offices into this topic. What is positive in Europe, that already many of agencies make land parcel information systems publicly open, and that farmers are able to use this, and it could be also used as important input for analyzing of Earth observation data. About food security, probably the most important activity is GeoGlam, which is run by Geo. And but we was not only focused on this global topic, we was also focused on the requirements of farmers and governments mainly in Africa, and there were the main topic again was mentioned, the agroclimatic knowledge gap. Yes, this was pushed as something very important. What is also necessary to stress here, that also for this geo activity and other, will be necessary to apply much more these FAIR principles of accessing of the data, because till now, for example, analysis of GeoGlam, which are every month, are mainly available as PDF, and for the future they will be necessary to have much more data in a machine readable form, and also with the better metadata. About the new satellite requirements, I already partly mentioned this, that there is important to be able in the future Landsat and Sentinel combine with commercial data to receive better resolution and also to have better time coverage of the region, because you know that there is often a problem to find some good data in this period. If we will have much more satellites, then will be bigger chance to receive the data in the days when we need it. I already mentioned something, but with implementation of Green Deal, we will need to be much more focused on some public-private partnership, because also paying agencies are collecting similar data like they are needed for farmers and other. I mentioned that food industry, insurance, they need similar analysis. And what is important for the future, to put resources together and to be able better cooperate on sharing data among all groups of stakeholders. Sharing, it is not necessary to have open data, as there is difference. Sharing could be also commercial, but it is necessary to thinking how we can do this. What we need is to make data better findable, accessible, interoperable, and reusable. So there is important much more and more focus on interoperability of the data, and it already started in some countries. Probably if we would like to reduce negative influence of farming, there will be necessary to put some public money to this, because probably farmers will be not able to cover all. As I mentioned, there is a big amount of overlapping needs, and we also need to change the view on the precision agriculture, because it will be in the future not only to produce more production, but also part of precision farming services or precision agriculture services need to be increase quality and have less negative influence on the environment. Some technical things which looks as very relevant is that one topic probably which could help us to understand what happened is to analyze historical data. There is some amount of the data, because Landsat is already here something like 40 years, and also climatic data there exist. And now with new artificial intelligence and APC, we can better understand current situation and better prepare model if we will use this historical data. What I see as also very important is to improve metadata for the future. I mentioned many times this discoverability of the data, but what is important for the future is that data will be linked with metadata, and we will be able automatically generate for any product metadata, which will be able to tell us what happened with this data. Because if some scientist or other person will need to use some product, they need exactly know the algorithms, they need exactly know what happened with this data, because without this the data has no value for them. So this is something where we will need to work much more in the future. We have the metadata, but usually the metadata are done manually, and with the products there is missing such information like provenance and other. Of course, there is important to make better standardization, better visualization. So this is shortly about this analysis. They will be possible to speak about this hours and hours, but we don't have so much time. So I am now closing this, and tomorrow I will try to make some conclusion during my presentation about white paper and strategic research agenda, where we will go deeply to some recommendation.
Yes, thank you, Karel. And you also can discuss with you in the air meet, so the coffee tables more informally after the end of this workshop, immediately after the end of this workshop. We have a few questions, but I think several has turned the 10 minutes into 15 minutes talks. Can I gently remind the next speaker that we aim for 10 minutes? And we have a few detailed questions here about the resolution, the price, I think. Can I ask then, I think it's Gerhard first, right? No, I lost. Yeah, they were going back and forth. So David, it's you. While you are sharing, can you, Karel, very quickly clarify the question concerning the price?
Yes, it is per hectare. Václav already wrote this to the text about this geogram. The IMIX data, this analysis, are till now only available in PDF form. Yes, so this is what I am pushing, and what will be very useful for the community to have this data in machine and readable form.
Yes, but in GeoGlam, this is we already work on that in Geo. So for every activity in the Geo work program, you are obliged to follow the Geo data sharing and data management principles, which means that you should make them interoperable. But we can discuss this. We don't have time to go into it. We can discuss this in the air meet or tomorrow, or if we have more time after, before 3:30. I want to make sure that we go through the entire program, more or less, before we end the stipulated time. So, David, the floor is yours.
Thank you. Let me confirm that you can see my screen. Then I can start.
Yes, you can go ahead. And we turn off the cameras.
The clock is ticking. 10 minutes to work on methods for agriculture, which is, of course, an obviously lost task, but I can give it a try and focus and give some focus points and some conclusions we came up with. So there's one short introduction into agriculture systems, some things you need to know when you work in agriculture, and how hard it is to find general solutions to it, because they are so diverse and so different systems, management, ecosystems. So there are many parameters to consider. But yeah, I think we still got a good job. And we put some focus points. We have 3 focus points. One is on precision agriculture. A second one, very dedicated one, is on crop type mapping, which is a very recent development and quite a lot talked about on various aspects. I will try to see some aspects which are normally missed about that. And there's a big point also on yield forecasts, with yield is very often the highest aim in agriculture application, to either maximize or yield. So if you're looking into agriculture systems, you can just see the large variety of agriculture systems on different soil, climatic regions, management practices. So just keep that in mind whenever you talk about agriculture. It's not one thing, it's a lot of things and a lot of systems in one approach. And another thing we talk about when we have the user requirements is the impact of scale. So you can have methods working on a field level where the farmer is the main user, and the decisions are made on a management level. So how to optimize in-field work, inter-field work. But it can also be on a regional or, let's say, national level on the government side, or common agriculture policy. So you have the same. Well, you're also working on food system, but on the scale you're working, you have completely different stakeholders involved and different problems. But still, you might have a common need for Earth observation-derived products, which foster information and help the decision makers on these different levels to work with that. Precision agriculture is, well, there's one definition I wrote down there, but actually precision agriculture is nothing new. It's actually when hundreds of years ago, a farmer had a small field. He also tried everything he had in order to maximize yield on his small field. So he also did precision agriculture in that respect. But of course, today, the bigger picture involves all kinds of information and communication technologies. So if you have on the center on this nice little graphs, which I took from from Gerhard and adapted. You have a nice field in the center, and yes, of course, we have Earth observation data with Copernicus, but you might also have drones or robotics in the field. Another aspect of that is, of course, you need geolocation, precision farming, so you need Galileo or another form of high precision coordinate system. You might also look into meteorological data and want to implement this. And all of that, since this IT component needs to be run on some IT infrastructure. So you also have the big data components and cloud source environment to run this, in at least for Copernicus, the DIAS system. And the farmer needs to keep track of all of that. So it's kind of a demanding task, and there's no easy shortcut to that. But I will come just what we have derived after assessing various use cases. What are the technical recommendation we can give from the project's point of view? What did we find? Which gaps did we identify? And think where we could have the most benefit in while improving. So the first one that is evidently missing is the provision of field level in situ data. So whenever methods are developed and benchmarked, you need to rely on in situ data, which is coming more and more relevant, where you have all these machine learning approaches and artificial intelligence. They rely on accurate, precise, validated field level in situ data. And this is most of the time missing or just very locally available. So for most applications, this is one of the largest shortcomings. So I think we can safely say the data is there. The in situ component is I think, lacking behind and needs to be improved. So there's no standardized long-term collection of field-based in situ parameters, which also follows standard protocols, open data sharing, FAIR protocols, etc. The same actually. Second recommendation goes along that way, is that we don't have a benchmarking system. So you can create and test your methods, but you don't compare these results with each other. So you don't have a testing approach. So you can't really say which one is better. And the last one, yes, we need higher spatial resolution, but this is of course not so easily manageable. So what is actually helpful would be to improve data fusion techniques, so that we have very high resolution commercial satellites and high resolution satellites from Copernicus, for example. And you can have two different approaches. You can say you want to go for higher spatial detail, or actually you want to create a denser time series which are affected normally by clouds. So these are two recommendations that actually would benefit the majority of use cases directly, without needing a new satellite or so on, but actually making a more efficient use of the available satellites and components. So this would be something that the top 3 recommendations we would give for precision agriculture, among others, of course. The second topic is the crop type mapping, so quite a specific one. And if you have been at one of the last conferences in this domain, in remote sensing or geo, you see there are hundreds of crop type maps out there generated very locally, sometimes proof of concept. So there are many crop types, and it's a very common application now, and it's very often used as a benchmark, as a showcase that the functionality of the software is working. However, I would like to focus on some technical details which are very often forgotten, or let's say not appropriately addressed, which actually come into place when you want to create a product of value to end users. So starting with, what is the definition of a crop type? So normally what is one crop type is not the same, because you have a crop cycle. You have different crops per year for every field. This is commonly just define the main crop as the crop type. Even that is a shortcoming which is not addressed. So for most crops, you will have 2 or 3 crops in various changes throughout the whole season. And also related to that, there's no common crop grouping which is agreed on. There's different approaches on making crop type groupings, but there's not a single crop type grouping which is agreed on. So also you can hardly estimate performance between individual classifiers, because you don't have the same crop type grouping as a reference. And you see quite some high accuracy maps and maps out there. For example, this one as an outcome for the Netherlands. And this is quite typical because they focus on a regional or on this type, a national level crop type products. Because of that, you do find quite a lot. But if you go into, let's go to global crop type maps or continental crop type maps, the one you find there mostly still have strong limitations. This was taken one snapshot from one producer, and you can see extremely many artifacts. So a global crop type map, which is accurate on a field level, and with decent crop type maps, is still largely missing. This is an observation we made. Another aspect, and this, let me guide you through this, is the timing of the classification. There are actually 4 different use cases that you can apply. Very often what you had is at the end of the season, you can see what has been the crop type for this year. But from a user's point of view, they're actually way more interesting. So maybe you can see even before the season, so the first one before the season, you can make an estimation on the crop type mapping. This would also be of value to some planners and forecasters. Let's say the one most people should be focusing on is the in-season crop type mapping. So actually as soon as possible in the growing season to estimate a crop type map, maybe with lower accuracy, but this would already have a value to them for trader, for logistic, for forecasting. And then of course, near retrospective for administrative even after the season for some statistical research. So the focus is very often on end of season crop type maps, which is a valid approach for scientific methods, but it's not the most valuable product that you can create. This one is actually in season. So this is something we is partly addressed in literature and the conferences, but not as much as it should be. And the same, if you go into the crop type mapping during the season, it actually becomes more complex because it depends on which in situ data is available at what time. And at least within Europe, there is data by the paying agency, which is called APIS or GSA data, which is to some degree shared. And depending when this becomes available, you get higher accuracy over the season. So you don't need to understand this plot in detail. I can share the slides afterwards. The point is that when you go to a crop type mapping as a function of time, like the start of season, depending on what data is already available, you start using EO data, but maybe you can have some information from previous crop type maps of that region. And so the accuracy goes as a function of time and depends in that area of interest. Do you have already data in the season or maybe at the end of the season? So what is missing very often is that you don't have this in situ data in time. So what you need to do is something which is either called temporal or spatial transfer learning. Either you need to apply pre-knowledge that you have and a method to a region which is out of the region where you trained it, or on into a time where you haven't trained it. So temporal and spatial transfer learning methods are needed if you want to come up with something of higher value in terms of a crop type mapping. So the recommendations here, crop type mapping is now well established, kind of even used as a benchmark tool to show proof of concept that it works in various conferences and different organizations and open software as well. And most machine learning approaches were tested from very shallow random forest to very deep transformer networks. So you can see everything is used and kind of used as a benchmark tool. However, most of them focus on end of season detection. Only few whereas in season, although in season has a very higher value to most users. And the necessary transfer learning approaches are very often underrepresented in discussion. So they make proof of concepts that they can create a crop type map in the area of interest where they have in situ data for that time, which is not the actual use case. There's also the in situ data. If we go to this APIS GSA data, but this is more a complex thing. It's still many open challenges that need to be addressed before you have this data early in season available to create very accurate in-season crop type maps just from scratch. And yeah, there are still standards missing for crop type mapping. It's not like a generic land cover land use where you have some guidelines to follow, but there's still, everyone's defining them themselves. You also don't have many accurate, precise continental global crop type maps yet. The focus is on regional, national level. And by that, I go to the last topic, yield forecast. You know, I'm rushing a bit, but we're a bit behind schedule. But we can share this slide and invite you to the table afterwards. We can go through the slides more slowly and in detail. So there are 2 points. There's yield estimation, which is the current assessment, but also the forecasting towards the end of the season. Both have socioeconomic input, and I think no one denies the value of those on various levels. And for estimating crop map, there are actually 3 different approaches, where you monitor the biomass production, like standard biophysical variables, but also you can rely on different either empirical models or some complex growth models. If you want to go into forecasting of crop yield, again, a similar situation, but maybe we can add the similarity scenario analysis, saying comparing this year to previous years, you can see that we expect a similar yield for the end of the season or for the harvest based on similarity in the vegetation pattern. And the recommendation for the yield forecast are again similar. You have different data sources coming into place. Remote sense data is only one of them, one of 4 or 5 different data sources that you need in order to create a accurate yield forecast. And from a remote sensing point of view, we need adequate crop-specific field data, and of course, frequent observations in real time, but also data continuity, not only for 1 or 2 years, but for 5 to 10 years. And interoperability has been mentioned a couple of times already today. So I come to my final slide. These are the technical recommendations for yield forecast. Again, the need for field in situ data, also from this subdomain of agriculture, is still the most limiting factor. Sensor-wise, there are also some recommendations that thermal infrared data with higher spatial resolution might be needed. But also there should be a research focus to include others than optical, also SAR and hyperspectral data, where we still see an opportunity to better make use of this data. A very common recommendation is, of course, always temporal and spatial resolution of optical sensors to be improved or increased. But I think the higher, the easier recommendations than that interoperability with other sensors in the meantime might be the best way forward for this specific subdomain of agriculture. And I hope I was on time, and I thank you for listening, attending, and I hand over to Bente again.
Thank you so much. That was very, very nice indeed, time-wise and also content-wise, of course. We have one question about the slides, which I totally understand. Yes, indeed, the slides will be made available. I talked to Noria, who is in charge of the EO4Agri website, and you will find the presentations there later today. And you will also be able to see a recording of this. You will also get the recording sent directly to your inbox, by the way. So you will be able to study a little bit more in detail what we have said. Yeah, thank you, Bernard, for giving us feedback. Excellent job, David, he says. We like feedback. We like to engage. Like I said, we really want you to ask questions and comment. I've run some polls. And for your information, I will see that there's a good mix of people who have expertise in the field that we are covering, and we have covered several fields. But there are also people who are learning and are curious about what this topic is. So just a very quick overview of the results of the polls I'm running. Thank you so much for participating in them. Nuria will, thank you, Nuria. She provided the link where you can find them, exactly where you can find them on the webpage afterwards. So now, finally, Gerhard, I think it's your turn.
Yes, thank you very much. My slides are shown,
yes,
are visible?
Absolutely.
Okay, thank you. So my presentation will shed some light on digital technology, which is a very important topic for the utilization of Copernicus in agriculture. So you will learn about the project task 3.5, which was the EO/ICT support improvements to stakeholder chapter, and about work package 4 as a whole, which has been addressing the end-to-end operational system assessment. it's been carried out in EO4Agri. I would like to acknowledge the work of the colleagues who contributed most of the work on technology in EO4Agri. Their names are listed here. They are from the companies EOX, eGeos, and Atos Integration. Next slide. Just a second. Here we are. The given time slot of 10 minutes allows me to give you only a teaser on the subject that has been addressed under the technology headline. And I will talk about the items here, shown here, and I must be very brief. I've actually, during the previous presentations, deleted slides from my slides deck to be short and meet the time. For further reading, I will point you to the deliverable documents where the bulk of the information collected in the EO4Agri project can be found. We've got a very nice introduction of or overview of from David on the applications and the technologies on the thematic side. I would like look at this from a slightly different point of view. Now, satellites are today producing between weekly and daily coverages of the global landmass with a precision and geometric resolution on ground that allow to go down to single agricultural field level. And the high temporal or observation frequency has made it possible that novel technologies, machine learning, for example, can be applied, which allow to monitor changes in the timing of seasonal events. David gave us good insights into what can be monitored. Even more so, people are enthusiastic that they can monitor harvest events, grass mowing events, greening measures, etc., which can be detected as well. And last but not least, we have heard already a number of examples which are important to improve the eligibility of farmers' claims for subsidy payments due to the schemes of the Common Agricultural Policy, the CAP. The digital transformation is the topic that I would like to spend a few minutes on, half a minute, 2 minutes on. This has fully arrived in architecture. And to characterize what it means, I would like to show here an example which was presented by Alan Bellward from the JRC at the 24th MAS conference in Dubrovnik. By the way, one of the many conferences attended by the EO4Agri project team. In the middle, it is a very busy picture, let me say. Addresses the CAP 2020 reform and the technical challenges and consequences related to it. I want to highlight on the left-hand side the big data blob, which indicates the big variety of data that need to be considered from various sources and gives also an indication of the big volumes of data to be managed. In the middle, the different involved stakeholders, use cases, related services are shown, and e-security aspects. And they are all, of course, like in this example, with a focus on the area monitoring system that is being developed and being built up in the EU and by the member states currently. And on the right-hand side, there is the policies and strategic viewpoints which impact on the technological implementations. Well, similar pictures like this could be drawn in the other sectors, in the other agricultural sectors, and you can find those information in the deliverables. So how to characterize digital transformation from the Copernicus and agricultural viewpoint? The principles are move the software to the data, so hybridized or in full. This is becoming inevitable to keep the data transfer bandwidth from storage to CPU within acceptable limits. The second principle is that we are replacing manual discovery processes and human interpretation of satellite imagery by full automatization of data handling and analysis using artificial intelligence, as has been mentioned already. And this is in particular necessary because we are dealing with very long time series of observation with large volumes of data. And third, we are establishing, and we can observe more and more in this direction, multi-tiered system architectures and operational service concepts. And this is leads us to a landscape of stacked cooperating providers to each efficiently concentrate on specialized tasks in the overall value chain and delivering their services to the end users. Now here I'm pointing to one of the deliverables that gives more information on this overall transformation, digital transformation, digitization that's taking place in the various agricultural sectors. I've mentioned that we find stacked services which make up the agricultural information landscape. And with this picture, I would like to characterize the general information architecture. At the bottom in the gray color, we have the services offered and established by the various suppliers. At the bottom, you see the ICT infrastructure, which is the compute and storage resources. And these are the cloud services provided by the big telecommunication industry. Then there is the service layer, which provides access to the base Earth observation data and to auxiliary information, such as LPS data, which was mentioned before. And on the top, we find the platforms which turn the Earth observation data in some sort of valuable information. And this valuable information is then exposed via application programming interfaces to the internet, and they can be consumed via these APIs by the client applications. Additionally, there are also offerings of full-fledged applications out there. Let us call them, or we have called them, agri apps in our project. As you see, there is a documentation on this overall architectural model that has been described to quite some details in the deliverable D4.1. Also, as was mentioned by Miguel before, from the various viewpoints, architecture viewpoints that are defined by the reference model of open distributed processing. A central element in the infrastructure and in the data provisioning part is the famous Copernicus Data and Information Access Services, the DIASs. They have been institutionalized. 4 of those DIASs exist. They have been institutionalized by the European Union and implemented via ESA contracts, and they are companies or consortia of companies supposed to operate services, and I will explain a little bit how these services look like in a second. They have got four years contracts, and we are all very keen to see how the models, the implementation models, and in particular the business models of the DSs will stay sustainable as sustainable services also after the first 4 years after EU funding will disappear. So what are these DS? It's not magic really, but complicating in the sense that they are storing a lot of data. We're talking about petabytes, tenth of the petabyte of Sentinel data, Copernicus data, and also data from other missions and auxiliary data. So in the first place, DS is a big, large data storage in the cloud. Then this DS provides, on the right-hand side, some kind of services for discovery and retrieval. And actually, we can observe that these services are following good standards, well-known standards. So DSs are in this respect interchangeable. They are delivering commodity access to Earth observation products, discovery and download. Furthermore, DSs are providing cloud resources for to run software for production of value-added data. So the DSs are not just a store, but they're also a compute resource. And the DS providers themselves have been tasked by the Commission to demonstrate their production capabilities also in the context of what is called Copernicus analysis-ready data. all the 4 DSs have shown that they are able to produce Copernicus analysis-ready data, which are the input data for further value-added processing. The details of this can be found again in the deliverable 3.10, as well as in the deliverable 4.1. Going to the right-hand side, the DSs are even more. They are offering a marketplace, which is a catalog of applications, of service providers, and these services or applications that can be found in that marketplace according to certain search criteria can, in an ideal case, then also be ordered by an end user and can be deployed to run on this platform. At the moment, this deployment of third-party applications shown in the marketplace is still a manual process managed by the DIAS providers, but we are seeing examples where the marketplace and deployment functionality and offering runtime platforms is becoming an automated commercial process, which will speed up the deployment and the uptake of applications quite significantly in the future. So the term agri-apps has been mentioned already a number of times. We will have a presentation afterwards by Laurent. So the applications that have been analyzed by the EO4Agri project and the catalog of application providers is also loaded on one of them, of the DSs, on the Mundi DS, and we will hear more about this in the next presentation. So the technology work in EO4Agri has, of course, gone also deep, and I can not reflect here in the 10 minutes the work of 2 years. These are just the headlines of where technology analysis, comparison, assessments have been done in detail. This is relating to data storage and access technologies in the cloud, primarily Earth observation, value-added processing technologies. Just give an example: Euro Data Cube or Data Cubes as a tool. Artificial intelligence, machine learning technologies. We have heard about examples given by David on crop type classification, for example. What are the technologies underlying that you can find in this document? Interactive computing technologies, nowadays very, very fashionable. Jupyter notebooks, working in Jupyter Lab environments. Cloud infrastructure, service provisioning, scaling technologies down to Docker Swarm, Kubernetes cluster environments, etc. Technology, and then an important chapter on the Open Geospatial Consortium web service technologies, which are an essential element in the architecture to guarantee and ensure interoperability between the various layers in the stack that I mentioned before. Again, 3.10 gives you the details on technologies. Well, I'm coming already to my last slide, and this is basically only a reference or referring to the deliverables of EO4Agri, where guidelines can be found. I mentioned already quite a number of times the 3.10 guidelines, focusing on information and communication technology in the Copernicus agricultural realm. But then there is also 4.5 developer guidelines for Copernicus-based systems in support of agriculture, and 4.7 report on good practices and end-to-end system evolution. So with this, I would like to conclude my presentation, and thank you for your attention.
Thank you very much, Gerhard. As you can tell, all of this is 2 years of very extensive work that we've done, and it's quite a challenge to present that in such a short time. So thank you, Gerhard, also for rushing through this. And again, I want you to take us up on the offer of meeting the speakers and discuss a little bit more in detail after we have heard from Laurent. So Laurent, are you ready to introduce us to the platform, to the Mundi platform?
Yes, I'm ready. I'm sharing my screen online. I think it's good now.
Yes. Oh, you can masquer that little thing at the bottom of your screen.
Yes, sure. Then here we can see the EO4Agri website, and from this point we could access directly to the catalog. This catalog is also accessible by the Mundi catalog website on the marketplace, and I hope on other DIAs. The catalog is the same for all the DIAs if they provide it. Then here you see that is named a catalog of different level of services. It's a specific website dedicated to referencement of different components. Here we have a first page with different level of informations, and this site is open and available. You can use it as you want. You see the address on top of the browser. What do you find inside? You have different components as data access. It's specifically all the platform in Europe available to access easily to different data and add value data also, as presented by Gerhard, for example, for the cap monitoring and the card products. In each tile, you could access directly on the provider and the website of the provider. All of our tiles in the catalog are the same and the same structure. The idea is to have a global view of different elements that you need to build intermediate or end user services. You have also the data sources. It's more or less included in data access, but here we focus on the different satellites in operation. Here you see the 1, 2, and 3 satellites by Sentinel in the program Copernicus, and we have reference also the private SAR and optical sensor. We have done the work to reference all of these providers interested in SAR technology and optical sensor technology to have a good overview of the different images under license and help users to find easily the best provider for each service. After we have referenced the application services, here classically we find the core services provided by Copernicus through different helping with different laboratories in Europe as ECMWS or CEA in France, etc. These components provide imagery services combined with different other data to have an analysis on thematic approaches. And at the end, as presented by Gerhard, we could find the Agri apps. Here we have a big list of different and several different services oriented through different usages. For example, I could open one. You have directly access to a short description and access to the website of the provider to understand what they provide and have a good view of all the providers in Europe. Probably we need to add someone, and the catalog is very open. If you have specific services, we can add it on the catalog to promote it. Then quickly, it's the overview of the catalog. We have also different access to easily have the information here. In all of these informations are bring in different forms to find the different information needs to build the different services that you need. I think the best way for you is to use it. I repeat, you could find it to you go directly on the EO4Agri website. We have a good reference on the web. You find the catalog here, and you go directly on the catalog. His name is also Marketplace. We could explain in more details each style, but it's very specific. And I think the time is at the end of this part of the webinar. If you have question, I'm at your disposition to answer on it. Thank you so much for this quick presentation, and not hesitate to ask question. Thank you so much.
Thank you very much, Laurent. That was very sweet and short. But I guess that the best way you can get to learn more about what you have on the platform is to go visit there. So maybe you can also provide a link in the chat so people can click on it and go explore. So we finished just on time, except we didn't have time to discuss that much. We didn't have time to answer so many questions. We do have now, Nuria, thank you very much for providing us with the link to the coffee table setup. We have set up a couple of virtual coffee tables already, but there are several others that you can organically gather around, you in the audience and the speakers. Laurent, I forgot to ask you before this meeting, actually, are you able to join one of the coffee tables to?
Yes.
Yes, excellent.
Pleasure.
Yes. So all you need to do is to go to the link that Nuria provided. We will slowly or gradually, not slowly, fastly, but gradually populate the room after we end this room here. But I think we can afford a couple of questions if there are any, or somebody who wants to join us in the room. It's possible also to raise their hand and ask questions. I don't see any immediately. Do you have any? Can you unshare your screen, by the way, Laurent?
Yeah, sure. Sorry.
So, thank you, all of you. Yes, and Nuria, thank you so much for reminding us that we can actually also join tomorrow. If you don't have time to go to the coffee tables today, you can join us tomorrow. And then you can see tomorrow, you will learn how all this information that we have gathered, they have resulted in different recommendations, so white papers and strategic advices and a roadmap. I think that even though you are here probably because you are more interested in the technology part of it or the scientific part of it, it's also interesting to learn what we have foreseen for the future and what kind of advices and that we have been able to collect collectively with the communities. Yes, I don't see any questions. Do you have any last comment, my speakers? No, you're ready to jump over to the coffee tables.
Yeah, I think.
Yes. Yes. Thank you so much. Thank you so much for now. I hope to see many of you tomorrow at 2 o'clock Central European Time. Follow us, EO4Agri, on Twitter, as Nuria was also saying. But first and foremost, you meet us in the air meet. Bye-bye for now.
Bye-bye. Thank you.